I think we'll be all right. So, everybody hear me okay in the back? Too loud? Good? Okay. So, we left off thinking about the elasticity of demand and the different kind of ranges. So, we'll kind of pick up where we left off. Last thing we talked about was on the in-class quiz, had some of the things that are going to influence whether or not a product is elastic or inelastic. So we said, we're measuring this price elasticity of demand. It's going to be elastic if it's greater than what? 1. Inelastic if it's less than 1. If it's equal to 1, we said it was unit elastic, right? So I kind of already mentioned this at the end of last class, but a couple things that are going to influence whether or not a good is elastic or inelastic, we can start to kind of think through. So I had somebody ask me the other day, I think they're in this about like financial versus economic consulting. And so the way I always think about economics is it kind of gives you a more less data-driven. I mean, it still is data-driven, but we think through the principles and they sometimes lead us to the answers if we don't have data available to us. So we can think about these different goods. So if I have a good and it has a lot of different substitutes. So think if I go into the grocery store and I don't care what kind of cereal, I just want a box of cereal. I don't care if it's chocolate, fruity, plain Cheerios. I just want to get, I want to buy a box of cereal. I have so many substitutes that if one of those boxes is $1 more, so it's not that much more expensive, although it's a relatively large percentage increase in price, if I could just pick up the knockoff brand that's right next to it, what am I more likely to do when I have that available substitute? Just buy the one that's cheaper, right? So when I have a lot of available substitutes, or you think about people with automobiles, there's so many different types of cars you can buy. People will haggle over the price of a couple $100s of a $40,000, $50,000 new car when they go talking with the car salesman, right? So if you've got a lot of available substitutes, you can substitute away when they change the price. So you're going to be very what? Elastic. You're going to be really responsive to even small changes in price. Same kind of idea for homes. There's so many homes that are available out there that people are really picky and choosy over a little small change in the price when you're talking about something that's going to cost you a couple $100,000 sometimes, right? So anytime we have more substitutes, we think about those products are going to be more elastic. Now, if I don't have a lot of substitutes, so for example, let's say I really want, Kelly School of Business, finance degree. Is there any other Kelly School of Business degree? There's only one, right? And so if that's what I want, there are no substitutes. What am I going to be in terms of the price? I'm going to be pretty inelastic. Some of you are choosing to go here. They increase the price quite a bit on you, right? And so we know that if we don't have a lot of substitutes for our product, our consumers can't be very elastic. Is that a good or a bad thing if I'm selling the product? Good thing, right? Bad for us. And this is where we'll start talking a little bit more today. When we're talking about elasticity, even when going back to module 3, when we're talking about complements, substitutes in production or consumption, whenever we think about the producers or the suppliers, we have to switch our mindset. All of us are consumers, all of us, right? Very few of us, we might have like a small, Etsy business or something, some of you, but right, not many of us are producers or suppliers. So we kind of have to switch our mindset to if I was a company selling this product, what would I want? So if I'm a company, I like it when I don't have a lot of substitutes for my product, right? That's why companies try to make things that are very unique, right? So you think about like Super Bowl tickets, right? There's no substitute if you want to go to the Super. There is just the Super Bowl this year. There's only one. So what happens? They can increase the price quite a bit. And what happens to the number of tickets they sell? Probably almost every year, they sell out, right? They sell the same number. It's very close to perfectly inelastic, okay? Another thing that we can kind of think about, the proportion of your income. If you're spending a large amount of your income on something, do you think you're going to be more or less, put more or less time towards that purchase decision? More, right? So what is that saying? When you're out there looking at the prices, you're going to be a lot more elastic, right? When something is a large portion of your income, you really care that you're getting a good deal. I think I used the example last class. If something is like a small portion of your income, like a pack of gum, or in light of recent events, my wife is making me cut this vice out, but I was, probably still am, terribly addicted to Diet Mountain Dew. right? So when I go to get a fountain drink from the gas station, I don't care if it's 89 cents or $1.50, I get it, right? I'm pretty inelastic because it's a really small portion of my income. I'm not gonna, I'm not that concerned about it. When it comes to something that's a much larger portion of my income, like housing, my wife can attest, I've got Excel spreadsheets that are looking at different attributes, different resale values. And I'm spending a lot more time looking at the actual price, okay? So that's another trait we've got. The length of the time to make a decision, I said last class, I kind of connected this to the number of substitutes. The more time I have, I think that's the first one I did, the more time I have to make a decision, what can I find more of? Substitutes. If I can find more substitutes, am I going to be more or less responsive to the price? Well, if they increase the price and I've got more time to find an alternative, I can be more responsive, right? So more time, I'm going to be more elastic. I can find other substitutes if someone changes the price on me. Less time, let's say, I don't know. This is not a good scenario, but let's say I really needed some money right now to pay off a debt. And I went out and I'm looking at kind of what personal loans are. Whatever the current kind of going rate for a personal loan is, if I need the money today, I have to accept it, right? I can't be very responsive to whatever, and that's kind of a weird one because the price is like the interest rate they're offering me, but it's the same idea, right? If I don't have a lot of time to find an alternative, I'm stuck paying whatever the current price is, right? You can even think about this in terms of like housing. If I'm moving to an area and I need a place to live and I'm looking at rental prices, yeah, I might think that rental prices are going to go down over the next year or two, but does that matter? Can I hold out and wait a year or two? No, I need a place to live today, right? So the less time you have, you can't be as responsive to price changes, okay? So if we look at some of these different products, just to kind of make sure I'm not feeding you a line of BS, right? When we think about like, this is like so weird now because A, people don't smoke as much and also there's lighters, but like, if you look like boxes of like matches, like the little, you would get from like a free from the restaurants, right? Even if you had to buy them, very small portion of your income. There's tons of other substitutes now. You can get lighters, all these other things. But they're really such a small proportion of your income. People don't really care what you could increase the price by 100%, 50 cents to $1, and people keep buying about the same amount, right? So small proportion of your income, very inelastic, right? We've got an elasticity measure pretty close to zero. Airline tickets. If I need to be somewhere in the next week, so I forget exactly short versus long run. When I pulled this from some economics database, I think it was something like you need an airline ticket within a week or something like that. So if I need to get somewhere, I need to look at an airline ticket in a week, I kind of have to pay whatever the current price is, or I risk not being able to find an airline ticket to where I want to go. So what am I going to have to be to the price? Pretty inelastic, right? I can't hold out and wait for the prices to change. Now, if I'm looking at long run, if I'm taking a trip 6 months from now, I can kind of shop around over the next few months, try to look for the best deal. What can I be? A lot more. Well, there's multiple airlines. I've got lots of substitutes. I've got more time. I should be really elastic. Sure enough, long run airline tickets, the elasticity measure that they had was above 1. There's now an elastic product. So the same product, but different attributes change of it could go from being an inelastic to an elastic product. Okay. Some of these other ones, things that, if I'm addicted to tobacco or nicotine, there's not a lot of other substitutes for me there. I'm going to be pretty inelastic. Sure enough, elasticity measures less than 1. And then other things I kind of mentioned, like new cars, right? There's lots of substitutes. I usually don't need a new car today. I can kind of wait around. I can kind of shop around. Maybe I'm holding out for, they offer like these seasonal, kind of deals. And so I've got more time to make a decision. All those attributes point to it being pretty elastic, right? So just a couple examples. I had some other ones. I don't know. I found this at one point and thought it was interesting, like different types even of the same product. So if I look at different types of alcohol, right? I've got beer versus liquor and all these other things. I've got different elasticity measures across all these goods. In fact, some of these, so if I look at like tequila, my wife loves tequila and she's very picky about it. Sure enough, the elasticity measure is above 1, right? Very elastic, right? Going to be very responsive to price changes because there's lots of available substitutes, right? And then, I don't know, you kind of go down the list. We could think about the different attributes of all these, but I just like this because it shows even within the same category of goods, those slightly different products, sometimes they could be going from inelastic to elastic, right? So we have things being, 0.1 all the way up to 1.8, right? So, like I said, we kind of touched on that at the end of last class, so not spend a ton of time on this. you probably expect to see a question on the quiz, question on the exam, which I may have printing kind of currently, that you need to kind of know these different three categories: time, substitutes, and proportion of your income, and how those would influence whether or not a good is more likely to be inelastic versus elastic. Okay. All right. Now, we also touched on this last class, but we'll dive a little bit deeper into it today. So slope and elasticity are not the same thing. So we have to walk before we can run. I was kind of talking about them as though like there was this inverse relationship. Remember, we said if something's perfectly inelastic, that means that when they change the price, I do what? If I'm not responsive at all, I'm going to buy the same amount, which means the quantity is at the same point, and I've got a vertical demand curve. They're changing the price, I keep buying the same amount. Okay. Now that slope of a perfectly inelastic demand curve we said would be what? It's kind of weird. Not zero, right? Infinity. What would have a slope of zero? Horizontal demand curve. So we've got a slope of negative infinity, but what's our price elasticity of demand? If we're completely unresponsive, our elasticity measure will be zero. So they're like the exact opposite, right? They're inversely related. However, that's not completely the most accurate statement when I'm saying that, but introducing the idea, it helps kind of introduce the idea, right? So if we actually look at the same demand curve, even if it's linear, so if I have a linear curve, the slope is the same at any point, right? Completely linear demand, slope is going to be the same everywhere. We actually have different elasticity measures along the same demand curve. So even having the same slope, if we're looking at different prices of a good, goods will be more or less elastic, right? So we have different elasticity measures at different points on the same demand curve, okay? Now, in general, what happens is as you move down the demand curve, right, we end up seeing that demand becomes more elastic. So let's just think about why. I think I've got a slide in here, but I think it'll help. I'll just kind of really make the point here. And let's see. Nope. Maybe I need some more colors up here. Is that clear now? Yeah, there we go. So let's say I've got this demand curve. Okay. If I'm thinking about the elasticity of demand, we said it's not the same as slope. And here, what we want to think about, anytime I have, we're going to talk about different elasticities. So right now we've got the price elasticity of demand. So this is how responsive is demand to changes in the price. So whatever is initially changing, that's what's going to go, or the very first word we're looking at, that's going to go in our denominator. The thing that is responding, here it's the elasticity of what is being responsive, demand, that's going to go, the second word will go in our numerator. Once again, that's not the most technical way of saying it, but it's a nice, easy way to remember it when we start looking at some of these other elasticities. Okay. So initially, if I'm thinking about, and I think I might have looked at this last class a little bit, but if I had the same $1 change in price up here, well, what's true about prices at this point in the demand curve? Are they relatively high or low? High, right? So maybe I'm going from like 100 to 99. So a $1 change is going to be a relatively what? Yeah, small percentage change in price, but my quantities, I'm pretty close to zero. So let's just say my quantities went from 1 to 2. Even though it's only an increase of 1 unit, if I go from 1 to 2, that's going to be a very large percentage change. So I'm going to have a very large number over a very small number, which is going to make my elasticity what? More likely to be above 1, or yeah, sorry. So I've got really large percent changes in quantity, really small percent changes in price. Okay. Now, as I move down to the lower part of my demand curve, right? And I might have said this backwards when I was reading off, talking now that I'm saying this. Let's say I go instead down here from $2 to $1. It's still a $1 decrease in price, but now what is my percentage change in the price of the good? Relatively large. and my 1 unit increase is going to be a relatively small. So down here, my elasticity is going to be more likely to be less than 1, or on the bottom part of my demand curve, it's more likely I'm going to be having inelastic measures. Okay? Now, just to kind of intuitively, if I'm starting out elastic, greater than 1, I'm becoming inelastic. At some point, the demand curve is going to be what? Equal to 1 or unit elastic. Right? Now, where that point is, we'd actually have to like look at the numbers and compute it. But we know that the unit elastic part of the demand curve will be somewhere in the middle. And then at prices above that, we're going to be having elastic. If we calculate the price elasticity demand, we'll kind of end up with elastic values. Where if we're at any price below that, we calculate the price elasticity demand, we're going to end up with inelastic values. Okay? So where we're at on the demand curve, right, is also going to, dictate whether or not demand is elastic or inelastic. Okay? Any questions on this idea? I might revisit this here in a second. Okay? So I put some actual values to this just to like compute it so we can kind of prove this to ourselves. If we use, the midpoint method that we had from last class. So just kind of a reminder, I don't have it all up on the slides, but how was I coming up with these percentage changes? How do I find a percentage change if I have two values? So I'm going from 30 to 20. How do I calculate using the midpoint method my percentage change in price? So when you calculate percentages in other classes or in other contexts, you usually have a base, right? So I think some people are getting confused with this. But for us, we're moving between the same 2 points. We don't care if the price is going from 30 to 20 or 20 to 30. We want to know what's the elasticity on that portion of the demand curve. We don't care what direction we're moving. So we don't want to have like we're starting at 30 or starting at 20. We want to take like the average of those 2 points or use that midpoint method. So we said if I want to find a percentage change, what do? I take the change and I divide it by the average. So what would I do here? The change was 10. The average of 20 and 30 would be 25, 10 over 25. Now, if I'm doing this mathematically, that gives me 0.4. I've written it up here in terms of a percentage. Remember, when we calculate these elasticities, these percentage changes using the midpoint method, they'll always be in proportion format. So if I get 0.4, what is that really telling me? That's a 40% change in the price. What's the change in the quantity? I'm going from 0 to 20. So the percentage change, I would calculate by taking the change of 20, dividing it by the average of, what's the average of 0 and 20? 10. 20 over 10 would be 2, or in terms of a percentage, a 200% change in the quantity. Okay? So that's how I'm coming up with these values here. Okay? So notice here, I've got a pretty elastic portion of the demand curve. If I continue, same $10 decrease or same $10 change in price, but I'm at a lower portion of my demand curve. Here, if I calculate my percentage change in price, it's going to be 10 over 15. Here, this would be what? 20 over 30. If I go ahead and compute those, I find those will both give me 0.67 or 67% changes in both of them. Well, if I have the same number, same percentage change, what's true about the demand curve here? This is my unit elastic portion. And then if I continue 10 to 0, well, it's just like the flip of these numbers. So I get 40 over 200. Now I see when I end up on that lower portion of the demand curve, now my demand is inelastic. Okay? Any questions on this? Yeah. So how would I come up with percentage changes, right? So if I want my percentage change in the price here, how would I find a percentage change? Using the midpoint method, we said we would take the change in that thing and divide it by the average. So what's the change in my price? Going from 20 to 10, 10. What's the average of 10 and 20? 15. 10 over 15 is? Put it in your calculator. If you can't do it in your head, 0.67. So we said when we calculate these percent changes using the midpoint method, it will give us the percentage change, but in decimal form, or in terms of like the proportional change, right? And it's not going to have it in terms of a percentage. I'm just converting it here to kind of give you nice numbers. If you really wanted to, you could change this. .67. Then if you calculate the same thing for the quantity, how would I find my percentage change in the quantity demanded? Well, what's the change in the quantity? Goes from 20 to 40, so 20. What's the average between 20 and 40? 20 over 30 is 0.67, right? That's where those two values come from. And I'm just kind of writing it in terms of percentages because that's how we generally think about elasticity, right? It's the percentage change in price and percentage change in quantity demanded. But anytime you have a percentage, you can convert it into decimal form by just moving the decimal 2 places. Yep. Any other questions here? Oop. So same kind of thing. As I move down the demand curve, it's becoming more and more inelastic, okay? So why do we care about this? Well, A, I might care about this if I'm a company. What dictates kind of what the current price is? Well, we had things like, here's demand, here's my supply curve, right? What's the current equilibrium price and quantity? Right here. Let's say, just to kind of review, since these were replacement videos, and hopefully, like I said, I'm expecting all of you have watched those, and if you haven't, it's going to be a rough exam, right? And so those module 3 videos would be exactly what we would have worked through, has all the kind of stuff in the document that I would have done in class. So if you haven't watched those yet, you need to, right? So if I've got my equilibrium, let's say all of a sudden there's a new technology and it makes producing whatever this good is cheaper, right? Easier. I can produce it using less money, right? There's some revolutionary technology like maybe ChatGPT making my workers more productive. What's going to happen to supply? It's going to increase. It doesn't matter if we're looking at supply or demand. Instead of thinking about up or down, I would always think about increases in either supply or demand as rightward shifts, right? You can think about it this way. I'm moving further away from zero. I'm increasing, whether it's supply or demand. What's a decrease in either supply or demand? I'm getting closer to zero. So decreases we will draw as leftward shifts. So let's say I have an increase in supply. As a result, that increases that equilibrium quantity, decreases the equilibrium price. Well, if I had to guess, just kind of looking at this, I may not be perfectly to scale, but I tried to draw it pretty obvious. Am I on the higher or lower portion of my demand curve here? Pretty low. So that price change, are consumers more or less likely to be elastic or inelastic? So let's think about it. That price change is going to be a relatively what? Small or large percentage change? Large, right? When the price starts out low, if I start out at 50 cents, even going to $1, that's a huge percentage change. So I've got a really large percent change in price, but when quantities are high, changes in quantity are going to be relatively small percentage changes. So when we're thinking about my elasticity of demand, it's the percentage change in quantity over the percentage change in price. So if this is going to be relatively large, this is relatively small, it's more likely this is less than 1, and we're likely going to be on the inelastic portion. If I'm a company in this industry, do I like this? Yes, that means, even though the price is going down by a lot, people aren't going to, well, actually here, I actually wouldn't like this in the context, right? Because if the price is going lower, right, am I selling that many more units? No, right? So I'm losing money by the fact that the price is lower. I'm not selling that many more units, so it's likely the amount of money I'm making is actually going to go down, right? So we can start to think about what direction this company would want the price to move. If demand was inelastic, if I have control to change the price, I would like this as a company, right? Because if I was a company and demand was on the inelastic portion, what would I do? If people aren't going to be very responsive to price changes, I'm going to increase the price, right? Increasing the price would be a good thing for me as a company. So when the price is actually going down, when demand is elastic, that's a bad thing for me. Because that just means I'm selling my product for less and people are still buying about the same amount, okay? So we're gonna now think about kind of this relationship between elasticity and total revenues for these companies. So hopefully we're all on board at this point with this idea that demand starts out as elastic. Eventually, when we look at lower prices, it starts to become inelastic. And there's this portion in the middle where it's unit elastic, okay? So what's gonna happen if I'm thinking about trying to map out at these different quantities? Let's see if I can get all of this. There we go. I'm just gonna map out for every single quantity here, what would the corresponding total revenue be? So we haven't really talked about total revenue yet, but I can think about total revenue is simply the price that I'm selling a good for times the number of units I'm selling, okay? So what's the total revenue that's generated from this demand curve? Yeah. Yeah, so if I'm a company in that industry, right, can I move the price? No, because there's many other companies, right? So I'm kind of forced to whatever equilibrium price change is. I was just saying, if I could choose as the company, what would I hope happens? If I'm in this industry, what do I hope happens? I would actually hope that the supply curve decreases. Now, I don't have any control over that. We're just saying, what would they like to see happen, right? Does that? Yeah, no, you're good. Don't apologize. It's a good question. So we've got these different ranges. I can start to think about what's going to happen to total revenue. And that's simply the price I'm selling the good for. And to your point, I have to charge whatever the current equilibrium price is. So let's just say the equilibrium price was right here, right? Well, we'll start out easier. Let's say the equilibrium price was right here. What's my total revenue? Yeah, how many units am I selling? 0. Okay, so I can map that point out. What about here? Well, I've lowered the price a little bit, right? But I'm now selling more units, right? Now, if demand is elastic, right? This is maybe not quite obvious, so I'll write some additional stuff out to support us here. If I have elastic demand, right? I know that elasticity measure is greater than 1. So what do I know is true about the percentage change in quantity relative to price? If I just rearrange this a little bit, or what would have to be true is that denominator is less than my numerator, right? So I know that when demand is elastic, my percentage change in price is going to be smaller than the percentage change in the quantity demanded. And if I'm lowering the price, I know quantity must be going up, right? I'm selling more units. So what's going to happen to total revenue here? Well, it's hurt by this reduction in price, but it's a relatively small percentage change. It's increased by this large percent change in quantity. So overall, which of these effects is going to win out? The one that's larger, right? So what's going to happen to total revenue as I start to lower the price? Initially, it's going to start to increase, right? At any portion on my demand curve that is elastic, as I lower the price, yeah, that's hurting my total revenues, but I'm seeing much larger percent increases in quantity, so I'm going to see total revenue is increasing there. So if I'm on the elastic portion of my demand curve as a company or in an industry, if the price begins to decrease, we'll actually see total revenues go up, okay? Now, what's going to happen instead if I'm over here? Well, if I sell this product for $0, what's my total revenue? 0 times anything is 0. So here, if I start to increase the price, what's going to be true here is my elasticity of demand is, we said, inelastic, so less than 1. So what's going to have to be true? That percentage change in the quantity demanded has to be less than the percentage change in price. So now, if I'm thinking about my total revenues being price times quantity, as I increase the price, that's going to be a relatively large percentage change. As I increase the price, people are buying less, but what is that percentage change in how much less they're buying? It's relatively small. Which of these wins out? That percentage change in price. So here, as I increase the price from this point where the price was 0, what's happening to my total revenues? They are increasing, right? So here's my kind of total revenues. Now, what's going to happen at the unit elastic point? This is kind of weird, and I'm drawing it much larger than it actually is. In practice and in theory, the unit elastic point is actually like one infinitesimally small portion of the demand curve. I'm just drawing it larger so we can kind of have a visual to it. But if I'm thinking about unit elastic demand, we know that percentage change in quantity over percentage change in price, it's equal to 1, which means what? The percentage change in quantity is the exact same thing as the percentage change in price. So now if I'm thinking about total revenues, whether or not I increase or decrease the price on this portion, every time I see an increase in price, what's it going to be matched with? The exact same percentage change in quantity. So what's going to happen to total revenues? No change. So if it really was this large, kind of our total revenues on the unit elastic portion, changes in price in either direction, our total revenues wouldn't change. Okay. Any questions here? I'm going to redraw this to make it a little bit, maybe simplified a little bit here. Okay. Yeah. These, yeah, it might look linear. They're supposed to be, yeah. I'll draw it. So I was using this to just connect this concept of the idea of elasticities. In practice, what is this going to look like? Well, I'll stack them again just to make it easier for us. We're always going to be looking at linear demand curves in this class. If you go to the next level of micro econ, you'll start to look at demand curves that have some actual curvature to them. It just makes the math harder. So here, if I'm looking at my total revenues, really in practice, like I said, there's going to be like one really small, just two prices in the middle moving between them. Your unit elastic point will just be a very small portion of the demand curve. Everywhere up here, it's going to be elastic. Everywhere down here, it's going to be inelastic. And so what you can think about is at that unit elastic point, what was true about total revenues? They were maximized, right? If I move to any quantity below that unit elastic quantity, right? If I increase the price from this point, I'm going to see that total revenues are going down, right? That makes sense. If people are elastic and I increase the price, they're going to be really responsive. They're going to buy a lot less. Whereas if I decrease the price from that unit elastic point, well, people aren't going to be very responsive here. So if I'm just lowering the price, they keep buying the same amount, my total revenues there would be decreasing, right? So it does kind of have this more like nice kind of U shape to it in practice. I was just kind of drawing it a little more simple when we were starting out there. Okay. Any other questions on this before we keep moving here? Okay, so where are we at on time? All right. So we kind of already talked through this, but we know that total revenue is price times quantity. And so really the elasticity is going to tell us what's happening to total revenue based off of kind of how we were just thinking through this, right? What's true about the percentage change in price relative to the percentage change in the quantity demanded. So I built like a little table here with some actual numbers. You can kind of prove this relationship to yourself. But notice initially, and I had a very simple demand curve. Starts at 5. At a price of 5, we're selling 0. So what is our total revenue? $0. And then if I lower the price to 4, I'll sell 1 unit. What's my total revenue? 4 times 1, 4. Lower the price to 3, 3 times 2, 6, etc. I can go ahead, and we won't waste time on this. If you want some extra practice, you could reproduce these numbers yourself in terms of how do I calculate my percent change in price? It's just the change in price divided by the average of these two numbers. So I can go ahead and compute that. I could then find the percentage change in the quantity demanded by taking the change, dividing it by the average, calculate the elasticity by taking my percent change in the quantity demanded over the percentage change in price. If I do that for all these values, what I'll notice is when demand is elastic, lowering the price did what to my total revenues? Increase them. Right? And then at that unit elastic point, if I lowered the price, what happened to my total revenues? They actually didn't change. That was kind of that initial graph I showed you where it can have like this little plateau at the top. If I was to like make this more fine, like do all the 1 cent increments, then we're going to have like only 1 cent where it's unit elastic. Here I'm kind of just using the integers to make it a little bit easier mathematically. But you could do this for every single possible, $5, $4.99, $4.98, $4.97. Just take a lot more time if you want to do this by hand. Right? So after that unit elastic point, if we continue to lower the price, well, now demand is inelastic. When we're on the inelastic portion of the demand curve, we said if we continue to lower the price, total revenues would then start to fall. Right? So we can prove this to ourselves with numbers. I'm not just making this up when I'm drawing these graphs. Right? This is what the numerical values will show you as well. Okay? It's just we could go through a mathematical proof, but that's kind of outside the scope of this class. Okay? So I didn't want to do that. So I always think about this as if you're interested in how price changes will impact total revenues, having these stacked graphs are really going to help you. Because let's say I'm on the inelastic portion of the demand curve. That's all I tell you. What do I want to do to price in order to increase total revenues? Well, if I'm somewhere on the inelastic portion, here would be my total revenues. How do I increase total revenues? I want to move this direction, right? I want to actually sell fewer units. How do I sell fewer units? I would increase the price. As I increase the price and sell fewer units, when demand is inelastic, well, people aren't very responsive. I'm selling fewer units, but that many fewer, and I'm charging a much larger percent for the price, so total revenues are getting closer to that maximum point. Right? If I'm on the elastic portion, what do I want to do to increase my total revenues? Well, if I'm on the elastic portion, in order to move to where total revenues are maximized, I actually want to sell more units. How would I sell more units? I would have to lower the price. So if we just wanted to summarize this, if my goal is to maximize total revenues, when I'm on the elastic portion, I want to move towards the unit elastic point. So I actually want to lower the price. Whereas when I'm on the inelastic portion, if I want to move towards that unit elastic point, what do I actually need to do? I need to increase the price. Okay. Yeah. I mean, that would be the goal if all we care about is total revenues. So what do we probably also want to factor in? I can always increase I can increase total revenues, but if it comes at a large cost, do I actually want to do that? No, I care about profits. So once we get down the road, we'll take what we know about total revenues. So yes, we're wanting total revenues to be high, but we don't care if we actually get to that maximum point for total revenue. We actually want to get to the maximum point of profits. So what kind of companies might actually try to get to that point? If they don't care about profits, these would be, there's a word for companies that don't care about profits, nonprofits. They might try to maximize total revenues, right? If they're getting the money from the government or somewhere else, they don't care about the costs. All they care about are the revenues. Yeah, but most companies that you're probably, I mean, maybe you'll end up working for a nonprofit, but ultimately most companies care about profits instead of just total revenues. Yep. But we've got to understand these concepts before we get to profits. Okay. Good question. Any other questions before we keep moving here? Okay. All right. So where are we at here? Make sure I've got plenty of time. So we've already kind of, oh, what do I want to do? All right. So I might skip ahead a little bit. So I'll show you this, and then if we have time, we'll come back to an actual data example. So I've really already kind of, said all of this. We just kind of wrote it down on the dot cam. But this is the idea that I said, when do we want to increase price? Well, we want to increase price when we're on the inelastic portion of the demand curve. When do we want to lower the price? When we're on the elastic portion, right? And there's always going to be this trade-off, right? As I increase the price, that's a good thing for me, but it comes at a cost of what? I sell fewer units. So just another way of graphically seeing this, I've kind of used a lot of arrows here, but if I'm looking at kind of an example, if I think about lowering the price from $4 to $3, here I'm on the elastic portion. So what should happen? If I'm lowering the price, I'm moving closer to the unit elastic point. Total revenue should be going up, right? We know that percentage change in the price, even though we're going from 4 to 3, you can think about it, well, before we were only selling one unit. We were selling it for $4. So my total revenue was 4. If I now sell this product for $3, I've lost $1 on that unit I was selling before, right? I was selling it for $4, now I'm only selling it for 3. But I'm now selling an additional second unit in which I'm now making $3 off that second unit. So I've lowered the price. I lost money on what I was selling before, but that loss was much smaller than the amount of money I gained by selling this additional unit. So what's going to happen to my total revenues here? They're going to go up by, if I lost $1, I gained 3, we'll go up by 2, right? Now, if I kind of continue to go, my arrow didn't move with me here, but if I go from 3 to 2, well, now those 2 units I was selling before, I'm going to lose $1 on each of them. Because before I was making $3 on each one, now I'm only making $2, right? So each one I lost $1, but at this lower price, I've now convinced another consumer or the same consumer to buy a third drink. So now how much am I making off this new third drink I'm selling? This new price of 2. So I lost $1 on the first 2 units, made $2 on this new third unit. What's happened to my total revenues? No change. This is my unit elastic point. And then if I'm on the inelastic portion, now if I lower the price by $1 going from 2 to 1, well, those 3 units I was selling before, I'm going to lose $1 on each one. And I've only convinced this consumer to buy 1 more unit. So on that 4th unit, I only made $1. So here what's happening to my total revenues by lowering the price? I lost 3 on the units I was selling before. I'm only making $1 on this new unit I'm selling. I've actually lost $2 in total revenue. Right? So just another way of kind of visually seeing this. It's really that as I'm changing the price, as I lower the price, it's a bad thing for me in terms of total revenues, but it's compensated for by an increase in quantity. So it really matters like what the relative size of those changes are, or which of those is a larger percentage change. And what tells us which of those will be a larger percentage change, that's our elasticity of demand. Huh? Yeah, technically, I'm probably a little bit less likely to phrase a question that way. But let's say I told you they lowered the price, and as a result, total revenues went up. I could then ask you, what portion of the demand curve are you on? Well, if you lower the price and total revenues went up, you actually know you're on the elastic. So yeah, if I could phrase the question in either direction. Probably a little bit more likely to phrase it the other way and ask you what's happening to total revenue. But if you understand the concept, you should be able to answer it either way. Is that what you were asking? Yep. Okay. Any other questions there? All right. So I actually already drew this for us. This was just when I stacked the graphs, right? So I just want to, sometimes I leave these blank slides to remind myself if I haven't done it at this point based off of what we've talked about in class. We've already done this, okay? So we've got this idea of total revenues and changes in price and whether or not we're on the elastic or inelastic portion. We're now going to talk about a couple other types of elasticities, okay? So one of them, it's going to kind of link up to some of the stuff we talked about in Module 3, which is maybe I want to look at cross-price elasticities, okay? So this one, if I'm looking at a cross-price elasticity, I want to know how does the change in the price of another good influence the quantity demanded of a different product, right? So here I'm going to have two different goods. It's going to look very similar to what we were doing with the price elasticity of demand, but it's now the cross-price elasticity of demand. So I'm looking at how does the percent change in the quantity demand for good X when I see a percentage change in the price of some other good Y, okay? So to kind of match up with what I was telling you, if I'm looking at a cross price, and this is where it gets a little, this is probably the trickiest one of all of them, just in terms of the less technical way of remembering it. I said anytime I want to calculate an elasticity, so all we've talked about up to this point is the elasticity of demand. So changes in the product for good X, how did that change the percent of the quantity demanded for good X, right? Price and quantity of the same good. Now I'm looking at, okay, I said the second word is always what's in our numerator. So how does that percentage change in some product X we're looking at? How is that responding, right? What is its elasticity to what? Now not just the price, not the price of that good, but a cross price. So now we're thinking about that first word is what's in our denominator. We're now looking at the percentage change in the price of another good Y, okay? So the cross price elasticity tells us how responsive good X is when you see changes in the price of some other good Y. So why might this be useful? So let's say I've got that when the price of good Y goes up or has a positive change, it increases, that as a result, people buy less of good X. So this is kind of a weird one. So say if the price of good Y goes up, and as a result, I actually buy less of good X, what must that mean those two goods are? So we know there's two options, substitutes or complements. This one's probably the trickier one, right? So maybe we'll start out here. If the price of good Y goes up, and as a result, I buy more of good X, what must that mean people are doing? Substituting away from good Y towards good X. So anytime I have a positive over a positive, this would tell me that these are substitutes. Notice if the price goes down and as a result of good Y, and as a result people buy less of good X, what must that mean? Well, Y is becoming cheaper. People stop buying good X, they buy good Y, that means they're substitutes. Now, if the price of good Y, say batteries goes up, and as a result, well, if batteries become all of a sudden $1,000, what happens to my demand for anything that requires batteries? It's going to go down. So that means those two goods are complementary goods, right? And same kind of idea. If I see a negative change, and as a result, people buy more, a negative change in the price of good Y, and as a result, people buy more of good X, batteries become cheaper, people are going to be more likely to buy goods that require batteries. Positive over negative or negative over a positive, this is always going to be an elasticity that is less than zero. positive over positive, negative over negative. This is always going to be a cross price elasticity that's above 0. So anytime I calculate this cross price elasticity of demand, if it's positive, that tells me they are substitutes. If it's negative, that tells me they are complements. Right? And then if we wanted to, we could still say they're like strong or weak substitutes. So the idea of here, let's say I had a cross price elasticity of like 0.1. So it's positive, so they're substitutes, but it's pretty close to 0, which means it's pretty inelastic, or that the amount that people are buying of good X is pretty unresponsive to changes in good Y, which means they're probably weak substitutes, right? There's not a lot of a strong relate. Now, if I had an elasticity of like, let's say -5, well, that's telling me that they're complements and that it's a very elastic relationship. That when the price of good Y changes, the amount that people are buying of good X changes a lot. So if they're more elastic, we would say that these are stronger complements, right? And then kind of, it gets a little bit tricky here because like it's negative. So what is a stronger relationship? It's actually a larger negative value, right? But we could still put these in the ranges of being above or below 1 to determine not only are they substitutes or complements based off their sign. So here with the cross price elasticity, the sign matters, right? It tells us something about what types of goods these are, right? Substitutes or complements. And then back to, is it above or below in absolute terms 1? That tells if it's an inelastic or an elastic relationship. Okay? And I likely won't focus as much on that part as I will just the sign telling us whether or not they're substitutes or complements. Okay? Any questions here before we keep moving? Yeah. If it's 0, what would you say the two goods are? That means that when the price of good Y changes, people don't change how much they're buying of good X. So those two goods would be completely unrelated. Yep. That's a good question, though. All right. So we've got these two ranges for our cross price elasticity. Another type of elasticity we'll talk about is the income elasticity. It also tells us something about what? When we had income changes, we said, so if I want to know about the income elasticity of demand, we have two types of goods, normal goods and inferior goods from module 3. So if I have my income elasticity of demand, well, once again, the word that comes second, not the most technical way of remembering it, but that's what's in my numerator. So how is the quantity demanded changing for good X? Or how is it responding to whatever the first word is? That goes in my denominator. Here, instead of a change in price, I've got a change in income, right? So let's think about this same kind of thing. If income goes up, and as a result, people buy more of a product, what is my elasticity, income elasticity demand going to be? It's going to be positive. Positive over positive is positive. Or if income goes down and people buy less, both of those would tell me this good is, yeah, this is how we would normally think about a good. That's a kind of a, not the, that's a way I kind of think about it. Like for most products, if I have more money, I'm probably going to buy more of them, right? So these would be our normal goods. Now, if I have more income and I buy less of this good, well, that must mean that these are products I was only buying out of necessity. So these are going to be, I was buying them because I was poor. As I have more money, I stop buying them. So these are actually inferior products, right? People stop buying used cars as they have more money and buy new cars. People stop buying, I don't know, well, what's a good kind of universal example? I always use like, you stop buying hot dogs and you start buying T-bone steaks, right? So there's these inferior products that if I have more money, I actually buy less of them, which would make this income elasticity actually negative, right? And once again, if I have less money and as a result I buy more of something, that must mean I'm only buying it because I don't have a lot of money. I'm buying out of necessity. it's an inferior product. Okay. So the sign of our income elasticity of demand tells us about not are they substitutes or complements, but is it a normal or inferior good? Okay. So kind of summarizing that idea, right? Positive income elasticity of demand, that's telling us it's a normal good. Negative, it's an inferior good. Okay. Any questions on, yeah. You're gonna have to speak up a little bit. I can't hear you. Oh, yeah, I think like in the Top Hat chapter, it talks about these necessity goods or luxury goods. You know, to be completely honest, probably not going to see anything in the quiz or the exam that pops up here. I'll probably focus more on just using that sign or calculating the income elasticity of demand. But yeah, you can do the same type of thing where we put it in ranges. Like if it's an inelastic product and it's still a normal good, we would call these necessity goods, right? So even though I have more income, I'm still going to buy about the same amount. You know, I don't know. This is like what I put gasoline, toilet paper, right? Like I have more money, I might buy more of it, but like not that much more. I need however much I need in my household to begin with, right? So even though it's a normal good, if it's inelastic, we would call those necessity goods. If it's greater than one, it's positive, right? It's still a normal good, but it's greater than one. These are going to be things that were really sensitive to income changes. So we would need, you know, even small. What do I have here? I have the elasticity being greater than one. So this would have to be like, I'm getting really large change in the quantity demanded. These luxury goods are typically going to have a really high elasticity because I'm going from like quantities of 0 to 1. So the percentage change will always be high, right? So even though my income change might not be, you know, even if my income change is 50%, that could be a pretty, it's, you know, a 50% increase in your income is huge, right? But if I wasn't buying a Rolex before, and now with my new income I am, 0 to 1 is always going to be what? 1 over 0.5. It's always going to be a 200% change in my quantity demanded. So these luxury goods, anything that has an elasticity greater than 1, we'll call luxury goods. And it's usually because we're going from quantities of like 0 to 1. So we're always going to have a really large numerator there. But so, I mean, in the slides we're talking about it. I would maybe focus less on it though than identifying it normal or inferior good based off the sign of that income elasticity. Okay. So I found this meme at one point. Is your income elasticity greater than 1 because being with you is a luxury good, right? So try that one out. Let me know the success rate. Okay. All right. So we've got one more. This is like really pretty easy. In fact, I won't even write this out. It's the exact same thing as the price elasticity of demand. We're just looking at the price elasticity of supply. So it's still going to be the percent change in price. That's the first word. That goes in our denominator. We're now just looking at percent changes in not the quantity demanded, but in the quantity supplied, right? Now, for us, there aren't as many things to talk about in this class with the price elasticity of supply. We don't connect it to total revenues or anything like that. You would calculate. I could use the midpoint method to calculate this the same way that we did for the price elasticity of demand. I've still got two quantities I'm moving between. They're just quantity supplied instead of quantity demanded. I've still got two prices. All the same principles apply. Now, the easy thing is with the price elasticity of supply, anytime price goes up, what happens to quantity supplied? My supply curve is increasing, so it's always going to be positive. Remember, when we calculated the price elasticity of demand, it had a downward slope. So we always were doing what? Taking the absolute value. Here, we don't have to worry about that, right? So it almost becomes easier when we're dealing with the price elasticity of supply. If it's less than 1, still say it's inelastic. Greater than 1, elastic. Equal to 1, we would say supply is unit elastic, right? So nothing really new here. We're just taking it and we're looking at the supply curve instead of the demand curve, okay? What do I want to do here? Got kind of an interesting example. So I want to make sure, though, that we have plenty of time to kind of go through this quiz. So if we don't have time for the other ones, maybe I'll start Tuesday's class next week with it. I think we'll still have time to touch on it here. So I'm going to publish this. Due date. Look here. 10. Do the end of class. We got 10 minutes. Oh, we got 15 minutes to go. Okay, yeah, we have plenty of time to do this. All right, so I've published kind of that in-class quiz. Once again, you can always find these on the homepage or under the quizzes tab. They just don't show up until I publish them here in class. So if I'm looking at this in-class quiz, got to preview it here. We'll work through it. Maybe. All right. All right, so we've got two questions here, really, that we're talking through. So this first one, right? If I had the current price of cigarettes is $4, I raise the price to $5, and I know that the current, right, before this price change, the price elasticity of demand was 0.4. If I raise the prices from 4 to 5, what's going to happen to revenues? Okay. So this is where you can try to memorize these concepts. If it were me, every question on the exam or a quiz, you can probably draw a picture that's going to help you, right? So if I'm thinking about the relationship of price changes and demand to total revenue, we should be thinking about like what we did today, where we stacked these graphs, where I've got my demand curve, and I want to know how does that correspond to my total revenue. Okay. Now we said when total revenue is maximized, what point of the demand curve are we at? Not 0. This is where demand is going to be unit elastic, or my price elasticity of demand is equal to 1, right? So this problem told you the elasticity of demand is 0.4. We said we start out elastic. As we move down the demand curve, we become more and more inelastic. So if I'm at 0.4, I know, and it's kind of easy. I mean, I shouldn't say easy. It's helpful in that if I'm looking at lower parts of the demand curve, if I know the unit elastic point is somewhere in the middle, the points on the demand curve below that are all going to be less than 1 or inelastic. That's one way I can remember this. Any point above that unit elastic point, my elasticity is going to be greater than 1 or elastic. Okay. So if I started out here and I told you I was on a point where the elasticity was what, 0.4, you know you're like right here, right? You're like start at that price of $4. So if you increase the price to 5, right? And this is where, you know, technically I'm telling you the elasticity between those 2 points. So you know it's not going to cross over that unit elastic point. So if I'm increasing the price here, what's happening to quantity? I'm selling less. So I'm selling less. What's happening to my total revenues? They're going up, right? So drawing it out, I think, is going to be a lot more helpful than having like all these like summaries written down. Okay, if it's elastic, okay, I can increase total revenues when I increase price. Because if I change this question and I said something like, what's going to happen if they lower the price from $4 to $3? Well, if they lowered the price from $4 to $3, what's going to happen there? If I'm on the inelastic portion and I lower the price, what's going to happen? Total revenues are going to decrease, right? So I think drawing this like stacked graph out when it comes to elasticity and total revenues is going to be helpful. Okay. Any questions on this one? Okay. So the next one, I've got a cross price example. So we've got what? I've told you the cross price elasticity is negative 3.2. Are the goods substitutes or complements? And what do you know is true about the percent change in the price of good Y relative to the percentage change in the quantity of good X? Okay. So we're starting out. I know that my cross price elasticity is negative 3.2. Okay. What was our cross price elasticity of demand? So that first word is what goes in our denominator. So cross price means I'm looking at a percent change in the price of another good across goods, right? So a change in the price of good Y, how is that going to influence the quantity demanded that someone's buying of good X. So I can think about this however I want. If I've got a negative value here, that would have to mean that as the price of good Y goes up, what's the only way this fraction is negative? If the change in the quantity demand of good X is that it decreases, right? So if another good gets more expensive, and as a result, I buy less of good X, what must be true? Yeah, they're complements, right? So it's hard to think about this sometimes. If it's easier, the one that's easy to think about, if something becomes more expensive and as a result, I buy more of another product, those products must be substitutes. That one I think is a little bit easier. And then, oh yeah, okay, if it's positive, it's substitutes. So negative must be when they're complements. So this is the idea. And maybe pick a good that really makes sense to you. I always use batteries because, like, to me, that's the perfect. You could use like peanut butter and jelly or, you know, other foods. You'll see a lot of econ courses try to use those, but everybody's different. All of you, if you have a product that needs a battery, you have to buy a battery to use it, right? So that one's a universal example that I know those are complements for anyone. So when batteries become more expensive, you use less of the products that require those. So like for a while, lithium was really expensive. And people like buying EV cars, like if you need replacement batteries, it was like increasing the price by thousands of dollars. And so what happened to the amount of electric vehicles people wanted to buy? Went down, right? They were complementary goods. So I know that these are complementary goods, but if in absolute terms, this is greater than 1, what do I know has to be true here? If I'm thinking about the relative size of that price change to the amount of the good X that they're buying, what's the only way this fraction is above 1 in absolute terms? What has to be true? The numerator has to be, once again, hopefully, I mean, this is review of fractions. I know my wife's an elementary principal. They start doing stuff with fractions in 5th grade. So we need to know that if something is greater than 1, the numerator has to be greater than the denominator, okay? So what's going to be true here is that percent change in the price is actually less than the percentage change in the quantity demanded of that good X, okay? So we've got complements, and that percent change in price is less than the percentage change in that quantity demanded for good X, okay? Any questions here? Okay with this? All right, so there's one more question on here, right? So for that first one, right, we had that we were increasing that price, moving towards the unit elastic point. Anytime we move towards the unit elastic point, we said revenues are going up, right? We then just said it's a negative cross price elasticity that tells us they're complements, and that percent change, that denominator, the percentage change in price must be less than the numerator, the percentage change in the quantity demanded. Okay. The third question, there is no right or wrong answer. You will get credit for responding to. On Tuesday's class, we're going to just be doing review. So I put that set of 20 questions. It looks like a practice exam, all multiple choice. That's how the exam's going to be, 25 multiple choice questions. So it has a few less questions on it, but that would be a really good study tool to start to review those questions. If you have questions on that practice exam or any other quizzes, because once we get to Tuesday's class, Module 4's quiz will pop up after class today. I'm not going to compete with you guys. All right, so Module 4's quiz will pop up after class today. So it'll be due by the end of the day, Monday. So any question on any old quiz is fair game for Tuesday's class. That practice exam, any question is fair game. I will likely tomorrow get up another set of questions that's just some more you can work through. It won't be like a full exam, but it'll have a few from Module 1 because that current practice exam kind of starts with Module 2 and doesn't have any questions for Module 1. We'll talk more about the specifics of the exam on Tuesday and kind of what you can expect with the last 5 minutes. So make sure before you leave, you do submit this quiz, right? But we were talking, I think, just to kind of make some interesting points. So we can talk about the things that influence the price elasticity of supply, just like we did with demand. So the main thing that we're going to talk about is time, and it works the same direction. The more time that producers have to find different materials, to find other workers, they can be a lot more elastic to price changes in a good. The less time they have, they can't find new workers. They're forced to kind of just assign hours to the current workers they have. They can be less elastic or they're more inelastic. Any kind of flexibility, right? That's really what the time thing is saying. If you have a product where I can use, I don't know, if I have to use lithium to make my batteries and the price of lithium goes up, I can't be very responsive to that price change, right? But if I can use, I don't know, tin or aluminum or any other cheap metal, I have more flexibility in my production process. I can be a lot more elastic to price changes in my product, okay? So I have an example that I think will kind of get at this. It's kind of crazy to think about this way. But in the 90s, the Sudanese slave trade, right? There's the humanitarian groups, and they went in and were like trying to buy slaves in Sudan and free them. The problem is, in order to purchase a slave, they had to offer a higher price, right? If I offer a higher price and people are very elastic in the slave trade, what's going to happen? Is supply going to go up a lot or not up by much? If you're offering me a higher price, I want to sell you more of a product. If you're going in and offering higher prices for slaves, what did people in Sudan do? They went out and found more slaves, right? They enslaved more people to have to sell. And so what they ended up doing is actually the humanitarians made the problem worse, right? Because the elasticity of supply was elastic for this slave trade, by going in and offering higher prices, supply, the percent change in the quantity supplied went up by a lot, right? So having some understanding of kind of economics, they could have maybe come up with some more, I don't know, ways that could have circumvented this problem, right? But it kind of goes to show we can take these principles we're applying, and it doesn't just have to be like I'm selling markers or I'm selling t-shirts, right? In fact, I won't take too much of your time, but just to end class, I put up a link here. This was like a little survey. They kind of did a similar thing where they went out and found probably like a lot of the people that roam around Bloomington and offered them like hypothetical drug prices for different quantities of goods. And they found that basically there's cross price elasticities between heroin, I think it was cocaine, and like beer. I forget all of the examples, but like cocaine and heroin, that was one. They found a negative cross price elasticity. So when heroin was more expensive, people actually bought less of cocaine, which means they must be not substitutes, complementary goods, right? I don't know, maybe after I get out of my heroin days, I need to get back up, and so I buy some cocaine. I don't know the story, right? But that's what they found with actual like individuals, survey data. So kind of taking these things we're talking about, putting this slightly more interesting context. I'll now let you guys get out of here. Tuesday, we'll be reviewing for that exam, which is in class next Thursday. Other than that, have a fun, safe weekend, and I will see you on Tuesday.